Determine the shortest distance between point P with x-coordinate 7 and y-coordinate 6 and the line y equals negative 2x plus 5. So we're going to start here by sketching out this scenario. I'm putting in a Cartesian plane with our x and the y-axis. Let's place the point P onto this plane. If x equals 7 is over there and y equals 6 is here, point P would be over here. The linear function y equals negative 2x plus 5 has a slope of negative 2, which means that it's going to be going down from left to right, something like that. And it has a y-intercept of positive 5. So we can sketch that like that. There's our y-intercept of 5. And then the question is asking us to determine the shortest distance between point P and this line. The shortest distance between point P and the linear function is going to be a straight line that will meet or intersect the linear function at a right angle, like that. And so this point right here, where they intersect, we're going to refer to that point as point Q. And the coordinates of that point are going to be, so the x-coordinate, we're going to refer to that as xq. And the y-coordinate is going to be yq. So to determine the distance between point Q and point P, we're going to use the distance formula. So we're going to call the distance between these 2 points d pq. And the distance formula would then be dpq equals, and then we're going to subtract the x-coordinates of the 2 points. So the x-coordinate of point P minus the x-coordinate of point Q, square that, then we add, and we subtract the y-coordinates of the 2 points. So the y-coordinate of point P minus the y-coordinate of point Q. We square that. So that's the distance formula we're going to be using here. So in order to proceed here and use the distance formula, we need to basically find the x and the y coordinate of point Q. So let's find first the x coordinate of point Q. There are 2 methods I'm going to be using here. You can choose whichever sort of works for you. I'm going to call them method 1. And in method 1, we're going to be using the slope formula to find the x-coordinate. So we're going to use the slope formula to determine the x-coordinate of point Q. So the slope formula in this case would be the slope of that perpendicular line that we're trying to determine the length of. So it's going to be the slope of line PQ equals. Then we subtract the y coordinates of the 2 points. We subtract the x coordinates of the 2 points. So let's plug in what we know. So the slope, well, the slope of this linear function, we're going to call that slope m1. That slope is negative 2. We get it straight from the slope y-intercept form. So it's negative 2. So the slope of line segment PQ, because it's perpendicular, it's going to be the negative reciprocal of m1, which means we take the negative 2, we multiply it by negative 1, which gives us positive 2, and then that 2 is moved across the division line into the denominator, and we get 1 over 2. So the slope of line segment PQ is a half. So we can put in a half. The y-coordinate of point P is 6 minus. The y-coordinate of point Q, well, we have an expression for the y-coordinate of point Q. It's this linear function right here. So we're just going to replace yq with this linear function. Like that. And then we're going to subtract the x coordinates of the 2 points. So the x coordinate of point P is 7. And the x coordinate of point Q is xq. And now I realize that up here it actually shouldn't really say x, it should say xq, because it's the x coordinate of point Q that we're putting in here. Okay, the x coordinate of point Q plus 5, like that. So let's simplify the numerator here. So we have a half on the left hand side. We can drop the brackets, which will give us 6 plus 2xq. And then we have to reverse the sign, so it's going to be negative 5 over 7 minus xq. We can combine like terms in the numerator. We're going to get 6 minus 5 is 1 plus 2xq. And now we just have to solve this for the x coordinate for point Q. So we can just cross multiply both sides. So we're going to get 7 minus xq on the left hand side equals 2 times 1 plus 2xq. We expand the right hand side. Which will give us 2 plus 4 times the x coordinate of point Q. And now we just combine like terms here. So we move all the x terms to the left and everything else to the right. So on the left hand side, we're going to get negative xq minus 3xq, which is negative 5 xq. And then we move the numerical constants to the right, so we subtract 7 from both sides. So on the right hand side, we're going to get a 2 minus 7, which is negative 5. And if we rearrange this, we're going to get that the x coordinate of point Q is positive 1. Okay, so that is the method 1 here, using the slope formula to determine the coordinate of point Q. We're going to do also at this point the second method. Okay, so method 2 here. That's going to be using a system of equations to find the x coordinate of point Q. And so the way that's going to work is that we already have one of the equations right here. That's going to be the function for this straight line here, for the linear function. And for so then we need to find the equation for this perpendicular line. We have the slope of the perpendicular line. It's a half. We have one of the points. We have point P. which means that we can plug the slope and the coordinates of point P into the slope point form for a linear function, and that's going to give us the second equation in the system of equations. Okay, so the slope point form here would be y minus y coordinate of point P equals the slope of line PQ times x minus the x coordinate of point P. So we can just plug in what we know. So it's going to be y minus the y coordinate of point P is 6. The slope of line segment PQ is a half. And then x minus the x coordinate of point P, and that is 7. Okay, so this equation together with y equals negative 2x plus 5 is our system of equations. And now we can solve this. You can solve it for x or y. Here I'm going to solve it for x. And you can do either substitution or elimination of one of the variables. What I'm going to do here is I'm going to substitute in y, so negative 2x plus 5, and replace the y here and substitute this expression into that first equation. So if I do that, I'm going to get negative 2x plus 5. So I've substituted it into that first equation. Minus 6 equals a half times x minus 7. Okay, and what I can do now, I can first of all expand this. I can multiply this half into the bracket. I also don't want to have any fractions, right? So I can multiply everything by 2. So I'm going to do both steps at the same time. I'm going to multiply the half using distributive property into the bracket. And at the same time, I'm going to multiply the left-hand side by 2 and the right-hand side by 2 to eliminate this 2 in the denominator. Okay, so if I do that, I'm going to end up with, and combine some like terms at the same time, I'm going to get negative 4x minus 2 on the left-hand side, and on the right-hand side, I'm going to get x minus 7. And if you solve this for x, you're going to get x equals 1. Okay, so, and obviously, so this is actually xq. So we found the x coordinate for point Q in 2 different ways. Obviously, it should be the same number. And so at this point, once we have the x coordinate of point Q, we can now find the y coordinate of point Q. And we can find that by simply substituting in the x coordinate back into that original expression right here. Okay, so I'm sort of running out of space here, so I'm going to see if I can add another page here. Okay, so there's a new page. So I'm going to take my x coordinate of point Q equals to 1. Okay, and we're going to use the slope for the linear equation that was given to us. So I can't see it here now. Where is it? It's going to be it was y equals negative 2x plus 5. I'm going to substitute in x there, equal to 1. So y equals negative 2 times 1 plus 5. Okay, and if I do that, I'm going to get a y coordinate of 3. So that's the y coordinate of point Q. Okay, so we have the x coordinate, We have the y-coordinate of the 2 points. So now we can use the distance formula to determine the distance between point P and Q. Determine the distance between P and Q. Okay, so let's just plug in the numbers. Actually, I'm going to first write down the distance formula again just to remind ourselves how it looks since it's on the previous slide. So we're going to start by subtracting the x-coordinates of the 2 points. I don't remember which one I subtracted from first. Hold on. X. Okay. It doesn't matter in which order you do it. Sorry, not X. It's P. Sorry. P. And then we subtract the y-coordinates. And then we take the square root of that. Okay. So we just can now just plug in the numbers. Okay. The x-coordinate of point P was, good question, I have to quickly check here. What was it? 7. The x-coordinate of point Q is 1. The y-coordinate of point P was 6. And the y-coordinate of point Q is 3. Okay. So now it's just a matter of evaluating this expression to get the distance. So 7 minus 1 is 6. 6 squared is 36. 6 minus 3 is 3. 3 squared is 9. And if we add up 36 to 9, we're going to get 45. And the question doesn't specify if it wants us to answer in exact form, which in this case will be an irrational number, a decimal, or in exact form, in which case we have to leave it as a radical. So we are going to answer in exact form. Of course, 45 can be simplified to simplest mixed radical form. It can be rewritten. We can factor 45 into 9 times 5. Take the square root of 9, and we can get 3 times square root of 5. So this is the distance between point P and that line segment, the linear function that was given to us.